yesterday one test was given to you. So here I am writing the solution of all those 5 questions. Please make a note of that and do your evaluations accordingly. First question was, a class of 20 boys and 15 girls is divided into n groups so that each group has x boys and y girls. You need to find the value of x was the first, then y also you have to determine, and finally the number of groups also you need to determine, that is n. So x, y and n we need to calculate there. Here class of 20 boys and 15 girls is divided into n groups, means we have to divide these 20 boys and 15 girls into n groups. So find the HCF of 20 and 15. Divide by division method also, but in your answers you will be always using the lemma. So 20, when you will divide, it will become 15 into 1 and remainder will be 5, and then 15 will be the dividend and it becomes 5 into 3 plus 0. So your HCF somewhere will be equal to 5. So that is HCF of these two, that is 20 and 15, will be giving you the number of groups. So total number of groups here will be 5. So number of students now in each group. Number of students in each group will be whatever the number of boys plus number of girls divided by the HCF. So it becomes 35 upon 5 is equal to 7. So first answer for this, that is n, your n will be equal to 7. So number of students in each group will be equal to 7, and then x, that is boys. So x will be equal to 20 divided by the HCF, that is equal to 4. Similarly y, the girls, 15 again divided by the HCF is equal to 3. So for this question your n will be 7, number of boys will be and girls will be 4 and 3. Let us go to question number 2 then. If alpha and beta are the roots of the polynomial or zeros of the polynomial that was given 3x square plus 2x plus 3, you need to find 1 upon alpha square plus 1 upon beta square. So you have to determine the value of 1 upon alpha square plus 1 upon beta square here. So one solution directly which you can go for this is, you can split the middle term if possible, or easier, then you get the value of alpha and beta, find the square, to put those values directly here, you will be getting the answer for this. So I am giving you the solution in an alternative way. As you know, what is A here is 3, B is 2, C is equal to 3. So I told you most of the time these questions are based upon your sum of the zeros and product of the zeros. So here sum of the zeros is minus b upon a, so that becomes is what, minus 2 upon 3, and product of the zeros will be c upon a, so that becomes 3 upon 3 is equal to 1. Now if you solve this 1 upon alpha square plus 1 upon beta square, you see this becomes alpha square beta square if you will take the LCM, and in your numerator you will be getting somewhere beta square plus alpha square. So this is there in the form of product alpha into beta, so I can write it alpha beta whole square because product is available with me, that is 1. And alpha square plus beta square, you see we know that alpha plus beta whole square is equal to what? Alpha square plus beta square plus 2 alpha beta. So I need to write in terms of the sum of the zeros the value of this alpha square plus beta square. So it becomes alpha plus beta square minus 2 alpha beta. So that is equal to what? Alpha square plus beta square. Please remember these points. These are very important points from understanding point of view also and algebraic identities point of view of also. So alpha square plus beta square directly you can put in terms of alpha plus beta whole square minus 2 alpha beta. So why I am writing this in this form? Because now this is the sum of the zeros, this is the product of the zeros, here again this is the product of the zeros. So I have converted this, what do I need to calculate, in terms of sum and product of the zeros, and the value from the polynomial is already available with me, and directly by substituting these values here, as you said ki alpha plus beta sum of the zeros is what? Minus 2 upon 3, so I can write the whole square, minus 2 into alpha beta means minus 2 into 1, and product is, so this is 1 square simply, so minus 2 upon 3 is what? 4 upon 9, minus 2 plus 4, 3 plus 9, and there it is, minus 2 into 1 is minus 2, and upon 1 means 1. So finally this is 4 minus 18 upon 9, that becomes as minus 14 upon 9 will be the solution of this. 1 upon alpha square plus 1 upon beta square you will be getting is equal to minus 14 upon 9 will be the answer for this question. So kindly keep a check. If any mistake is there, accordingly you can reduce the marks. Then question 3. Question 3 somewhere was, if alpha beta are the zeros of the polynomial 2x square minus 5x plus 7, then you need to write a polynomial whose zeros are given 2 alpha plus 3 beta, and another zero is 3 alpha plus 2 beta. So as already I have told you, to write the quadratic polynomial in terms of these zeros, standard form is x square minus sum of the zeros into x plus product of the zeros. So better you write these zeros there. Sum of the zeros means 2 alpha plus 3 beta plus 3 alpha plus 2 beta into x, and plus product of the zeros is 2 alpha plus 3 beta into 3 alpha plus 2 beta, whatever the zeros are given there. Here x square minus, you see 2 alpha plus 3 alpha, 5 alpha, 3 beta plus 2 beta, again 5 beta into x, and plus if you multiply these, 2 alpha into 3 alpha makes it 6 alpha square, and 2 alpha into 2 beta is 4 alpha beta, plus 3 beta into 3 alpha is 9 alpha beta, plus 3 into 2 is 6 beta square. So here it is x square minus 5 I can take out. So alpha plus beta into 5x. Here it is plus 6 alpha square plus 6 beta square plus 4 plus 9 is 13 alpha beta. So 6 alpha square plus 6 beta square and plus 4 and 9 is 13 alpha beta. I hope you are getting me. Again, I am getting back because these alpha and beta are the zeros of this polynomial. So I am trying to write it in terms of sum and product. So as I told in previous solution to you, alpha plus beta state is minus b upon a, and here you see minus b upon a is your 5 upon 2. So 5 upon 2 into 5x. Alpha plus beta, here already it is minus 5, so minus b upon a will be plus 5 upon 2 into 5x, plus here now you see 6 is common, so inside the bracket I can write alpha square plus beta square, and plus 13 alpha beta means that is the product c upon a, so that is I am getting here is 7 upon 2. So alpha beta is the product. So as per this polynomial, because alpha and beta are given the zeros of this polynomial, so c upon a will be 7 upon 2. So x square minus 5 into 5 is 25 upon 2x plus, now look at this, here it is 6. As I told in previous question, alpha plus beta whole square will always be equal to alpha square plus beta square plus 2 alpha beta. So on behalf of this alpha square plus beta square, I can write in terms of alpha plus beta whole square minus 2 alpha beta and close this curly bracket, plus here it is 13 into 7 91 upon 2 and close this bracket. Now x square minus 25 upon 2x plus here 6. What is alpha plus beta? Again minus b upon a, that is what? 5 upon 2 whole square. Minus 2 alpha beta means minus 2 into what? 7 upon 2. So I can write it 7 upon 2 and then close this bracket plus 91 upon 2 and close this bracket. So finally you are getting x square minus 25 upon 2x plus 6 into 25 upon 4. 2 you can cancel, minus 7 plus 91 upon 2. So here it is 2 2s are and 2 3s are. Do these calculations. X square minus 25 upon 2x. So it becomes 25 3s are 75 plus 75 minus 7. 75 minus 7 plus 91 upon 2. 75 minus 7 is 68 plus 91 upon 2. This is 25. 3s are 75 upon 2 minus 7 upon 1 plus 91 upon 2. So do this calculation somewhere in your rough margin. 2 will be the LCM. Here it is 75 minus 54 plus your 91. So 5 and 1 6, 7 and 9 16 minus 54 upon 2. Upon 2, so that becomes equal to 56. So x square minus 25, or you can check these calculations correctly, please see, and finally you can check your answer. That will be there in the quadratic polynomial whose zeros are 2 alpha plus 3 beta and 3 alpha plus 2 beta. This was your question number. Please pay attention here. You need to check these calculations very carefully. This is minus 7 within the bracket. This bracket you have to solve together. So now it becomes somewhere is 6 into, this was there inside the curly bracket, 6 into 25 upon 4 minus 7, like this, and plus it was 91 upon 2. So if we'll be solving this part, this will become x square minus 25 upon 2x. So for this particular equation, you will be getting 41 after the solution of this. So your answer will be x square minus 25 upon 2x plus 41. So please check 6 into 25 upon 4 minus 7 plus 91 upon 2 will give you 41. And then your answer will be x square minus 25 upon 2 into x plus 41. That will be the final answer for this. Then your third question was, fourth question was, find the zeros of the polynomial. I hope all of you are clear with this. 6x square minus 3 minus 7x, and verify the relationship. So please arrange this accordingly. 6x square minus 7x minus 3. Split the middle term, that is 6 into 3 is 18. You know 6x square minus 9x plus 2x minus 3. First two and last two. So here 3x is common, it is 2x minus 3. When nothing is common, plus 1 is always common, 2x minus 3. So 3x plus 1 into 2x minus 3. So your two zeros, when you put this is equal to 0, it will be minus 1 upon 3, and this will be 3 upon 2. These two will be the zeros. So minus b upon a, here is 3 upon 6, that is 1 upon 2. And in your verification, minus 1 upon 3 plus 3 upon 2, you can check 6, that is minus 2 plus 3 is equal to 1 upon 6. This is so here a, b and c. B is minus 7, so b upon a will be 7 upon 6, and if you find the sum of these two, that is also equal to 7 upon 6. Your product c upon a. C is minus 3 upon 6, that is minus 1 upon 2. So if you check the product of these two, minus 1 upon 3 into 3 upon 2, 3 getting cancelled with 3, and that also becomes equal to minus 1 upon 2. So that is the verification done with respect to the coefficients. 7 upon 6, 7 upon 6, minus 1 upon 2, minus 1 upon 2. And last question, that number 5, 1 0 is given, and we have to find the remaining 2. I hope you all are clear with that. So x plus 1 will be the factor there, and we can divide that polynomial. 15x cube plus 14x square and minus 3x minus 2, and please check your quotient. That will be coming in terms of degree 2, because you know cube when will be divided by the degree of 1, so you will be getting your quotient in terms of degree 2, and it will be coming somewhere 15x square minus x minus 2. Finally you need to split the middle term here to get the two remaining zeros, and by splitting these you will be getting minus 1 upon 3 and 2 upon 5. These will be the remaining two zeros for your question number 5. So each question is getting 3 marks. Please check your answers accordingly. Thank you.